Welcome to A-Level and AP Physics. In today's lesson, we will discuss typical type of questions on electricity and radioactivity from October number 2020, paper 1. For question number 31, it is given to us a stationary particle is in electric field. The only force acting on the particle is from the electric field. In which case is the electric field means the capital E is equal to 5.0 times 10 to 5. But if you look at options, for each option the force on the particle is given and type of particle is also given. So this is true for all options. You can see force is given, particle is given. For C, force is given and particle is given. Again, force is given and type of particle in the field is also given. Now the first thing we need to understand is that what is the relationship between force and electric field? Electric field simply E is equal to the force on the particle divided by charge on particle. So Q is the charge on particle. So simply we have to use E is equal to F over Q and we need to calculate value of E for all these options. So for option number A, E is equal to F over Q. So F is given, that is equal to 1.6 times 10 to negative 14. And the charge on electron is 1.6 times 10 to negative 19. If we solve this one, simply we can cancel 1.6 with 1.6. Our final answer will be 1.0 times 10 to 5 volts per meter. So this is not what we are looking for. I mean, this is not correct option. Our answer has to be 5.0 times 10 to 5. So A is not answer. Now, if you look at B now, so I will be writing here for B. E is equal to F over Q. So the force acting on the particle is given, that is 3.2 times 10 to negative 14. We have to divide this one by the charge on particle. In this case, our particle is alpha particle. So the charge on alpha particle is 2 times the charge on electron. So we can say this is 1.6 times 10 to negative 19. So in this case 3.2 we can cancel with 2 times 1.6. Our final answer in this case is also equal to 1.0 times 10 to 5 volts per meter. So this is also not correct option, so we can cancel this one. Now if you go to part C, for option C it is given to us E is equal to the force on the particle is given, that is 8.0 times 10 to negative 14 divided by charge on alpha particle. So charge on alpha particle is 2 times the charge on single electron. Now if we solve this one, in this case our final answer will be 2.5 times 10 to 5 volts per meter, and this is also not correct option, so we can also cancel this one. Now if we go to our final option D, it should be the answer. E is equal to F over Q. Force in this case is given 8.0 times 10 to negative 14 and particle is proton and the charge on proton is equal to the charge on electron. So this is 1.6 times 10 to negative 19. If we solve this one, 8 divided by 1.6, we will get 5.0 here. So we can say this is 5.0 times 10 to 5 volts per meter. So our best possible answer for this question is D. So D is the answer. Concept you need to understand is E is equal to F over Q and Q is charge on particle in the field. So this is charge on particle in the field. So we can simply say in the field. Charge on particle in the field. And F is the force here. For question number 32, it is given to us a constant potential difference is applied between two horizontal metal plates. A charged oil droplet is held stationary, means is at rest by the electric field between the two plates. It is also given to us as some of the oil evaporates, the droplet loses mass and starts to accelerate. Its charge remains constant. We need to find out in which direction does the droplet accelerate and which change needs to be made to the separation of the plates in order to stop this acceleration. For this question, it is given to us particle is stationary, means the droplet is stationary. It simply means that its velocity is equal to 0. As velocity is equal to 0, it simply means that forces acting on this droplet are balanced. Or simply we can say F net on this droplet, or which simply we can say particle is equal to 0. Now we need to understand what kind of forces are acting on this droplet. The one force acting on this droplet is weight of this droplet because it has mass, so weight is acting on this particle. Weight means force of gravity is acting on this particle, and force of gravity is always downwards, so this is direction of force of gravity on this droplet. This droplet has charge and this droplet is inside electric field. So the electric force has to act upwards, then resultant force on this particle will be equal to 0. So this is direction of electrical force, Fe. Fe is equal to Eq, means the electrical force is equal to Eq. It is also given to us that some of the oil evaporates, droplet loses mass. If the mass of the droplet decrease, it means weight will decrease. So we can redraw this diagram, free body diagram. So weight decreases, so W decreases, but it is given to us its charge remains constant. As Q remains constant, E is also constant. It means electrical force remains constant. So in this case, electrical force is greater than weight now. As electrical force is greater than weight, it simply means that particle will accelerate upward because the resultant force is upward. So in this case, resultant force is upward, so acceleration is also upward because acceleration and resultant force always in same direction. So first question was, in which direction droplet accelerates? So droplet will accelerate upwards. Now let's move on to second part. Question is asking us which change needs to be made to the separation of the plates to stop this acceleration. We need to stop this acceleration. It simply means that we need to make resultant force equal to 0. But if you look at electrical force now, Fe, this is equal to Eq. But E is equal to delta V, means the potential difference between plates divided by separation of the plates, means the separation between plates. Now if you want to decrease electrical force, question is asking you what change needs to be made to the separation of the plates. So if we increase separation, mean if we increase D, then electrical force will decrease. So simply we need to say that we need to increase separation. So there are 2 points. First thing, acceleration has to be upwards. The second, we need to increase the separation. So if you look at option D, you can see it is given to us. Acceleration is upwards and separation has to increase. So D is the right answer for this question. For this question, it is given to us two resistors R1 and R2 are made from wire of the same material. If material is the same, it means the number density is the same. So the number density for resistor 1 and for resistor 2 is the same. So we can say N is same. It is also given to us these resistors are connected in parallel to each other in a circuit as shown. So as you can see here, we have two resistors R1 and R2. Diameter of R2 is half the diameter of R1. From here we can say cross-sectional area of resistor 1. This has to be equal to 4 times the cross-sectional area of resistor 2. So simply we can say A1 is equal to 4 times of A2 because D1 is equal to 2 times of D2. And area is equal to, means the cross-sectional area, this is equal to pi by 4 D squared. So if D is double, it means area is 4 times. So that's the reason we have written A1 is equal to 4 times of A2. It is also given to us resistance of R2 is 3 times the resistance of R1. Resistance of R2 is 3 times of the resistance of R1. So R2 is equal to 3 times of R1. But if you look at these two resistors, they are connected in parallel. So it means V2 means the potential difference across the second resistor is equal to potential difference across first resistor. But for second resistor V2, we can simply write down this is I2 times R2 is equal to I1 times R1. But R2 is equal to 3 times of R1, and this is equal to I1 times R1. So this is I2. From here we can find out that I1 is equal to R1. R1 we can simply cancel. So the I1 is equal to 3 times of I2. So this information we can get from the given resistance. For this question, we need to find the ratio between drift speed of free electrons in R1 and in R2. So we need transport equation. According to transport equation, I is simply equal to NQVA. We can rearrange this one. We can say I over VA. This is equal to NQ. But NQ is constant for wire 1 and it is also constant for wire 2. Simply we can say it is equal to constant. We can write down then I over means I1 over V1 A1. This is equal to I2 divided by V2 times A2. We can cross multiply, so means we can multiply this side with I1 and we can multiply this one with I2. So we can write down I1 V2 times A2. This is equal to I2 times V1 times A1. We need ratio between V1 and V2. So we can divide this side by I2 V2 times A1. So we also need to divide this side by I2 times V2 times A1. Now we can simply cancel. On this side, we can cancel I2 with I2. We can cancel A1 with A1. And here we can cancel V2 with V2. So we simply left with V1 over V2. This is equal to I1 times A2 divided by I2 times A1. Now, if you look at value of I1, I1 is equal to 3 times I2. So we can write down here I1 is equal to 3 times I2. If we write down value of A1, so we just write down A2 here. So we can plug in value of A1. A1 is equal to 4 times A2. So we can say this is 4 times A2. Now simply we can cancel I2 with I2 and A2 we can cancel with A2. So simply we left with 3 by 4. And this is the ratio between V1 and V2. So our answer for this question is B. For question number 34, it is given to us a student describes potential difference as the energy transfer per unit charge. Which statement about the energy transfer is correct? First of all, let's try to understand what is the difference between potential difference and EMF. EMF simply we can say this is amount of chemical energy, or you can say other forms of energy. Amount of other forms of energy converted into electrical per unit charge. Chemical, as you can say, other forms. So we can write down here other forms of energy converted into electrical energy per unit charge. So this is how we can define EMF. Chemical to electrical energy per unit charge, that is called EMF. For potential difference, this is just reverse. We can say electrical energy converted into other forms of energy. So we can say electrical energy converted into other forms of energy per unit charge. Other forms of energy per unit charge. So that is what we call potential difference per unit charge. Now if you look at options, it is given to us, it is from electrical energy into other forms. So this energy transfer is true. So this is potential difference. So this is our answer. If you look at option B, it is from other forms into electrical. So this one is wrong actually. This is about EMF. So option B is not correct. If you look at option C now, it is given to us it only takes place inside a power supply. But this energy transfer means electrical energy can be converted into other forms in other devices as well. Means this energy transfer also can take place inside resistors. It also can take place inside motors and so on. So option C is incorrect. It is saying only. But this energy transfer means electrical energy can be converted into other forms in other devices as well, not only in power supply. But if you look at option D, it is also given to us it only takes place inside resistors, but it can also take place inside power supplies. When due to internal resistance, electrical energy can be converted into other forms. It also can take place inside motors and other devices as well. So this is also not right. This is incorrect. It is saying only. So this one is wrong. So option D is also incorrect. So our answer for this question is A. For question number 35, it is given to us a metal cube has a resistance of 4 ohms between opposite faces. 10 of these cubes are put together to make a cuboid of 1 by 2 by 5 cubes, as you can see here. So this one is the cuboid. There is no extra resistance when the faces of the cubes touch each other. What is the resistance of the cuboid when connected between faces X and Y? Means if we connect power supply here across faces X and Y, what is the resistance of this cuboid? First thing we need to understand, if we look at these cubes, so this is first cube, this one is the second one, third, fourth, and fifth. This one is the 6, 7, 8, 9, 10. If you look at these 5 cubes, they are connected end to end. It means these 5 cubes, they are connected in series, and these 5 cubes, they are connected in series. So simply we can redraw this circuit. So we can connect these cubes, we can treat them as resistors. So the first row, we have 5 cubes connected in series, or we can say 5 resistors connected in series. And in the second row, we have 5 cubes connected in series. It simply means that we have 5 resistors and they are connected in series. So this is how we can redraw the circuit. So this is our point X and this is our point Y. Between X and Y, power supply is connected. So here we can connect power supply. Now each cube has a resistance equal to 4 ohms. So we have 5 cubes connected in series. It means the total resistance of 5 resistors are 5 cubes. This is equal to 20 ohms. And the total resistance of 5 cubes in the second row is also equal to 20 ohms. Now simply we need to find out the total resistance of these two resistors. So this is our point X and this is point Y. So these are two identical resistors. So we can say total resistance is equal to product of these two resistors divided by sum of their resistance. So 20 plus 20. Now if we solve this one, in this case we'll get this is 400. 20 by 20 means 400 divided by 40. So 20 plus 20 is 40. So our final answer in this case is simply equal to 10. Simply, if you look at these two resistors, they are identical and they are connected in parallel. It simply means that the total resistance is equal to the resistance of one resistor divided by number of resistors. So one resistor resistance is 20 and we have only two resistors. So it means the total resistance of these two resistors is equal to 10 ohms. So that's the reason our answer for this question is C. For question number 36, it is given to us a cell is connected to a fixed resistor. Over a long period of time, the internal resistance of the cell increases. What is the effect of the increase in internal resistance on the electromotive force of the cell and on the power dissipated by the fixed resistor. First of all, let's try to sketch this circuit. So in this case, you can imagine that this is our battery, and this battery has internal resistance. We can say EMF of this cell is E. And there is another resistor is connected, that is external resistor. And the resistance of external resistor is fixed. You can say the resistance of external resistor is capital R. So this is our cell actually. If you look at the cell, so this is cell, and the internal resistance of this cell is small r. Now if R increase, it has no effect on EMF. So this is the first thing we need to understand. If R increase, EMF does not change. So this is the first point you need to understand. EMF does not change. If R increase and EMF does not change, then we can find current in this circuit. So current is equal to EMF over total resistance. Now if R increase, it means I will decrease. If I decrease, then the power dissipated by this resistor, we can write down P power dissipated by R. This will be equal to I square times R. As the resistance of external resistor is fixed, so if I decrease, it means power dissipated by external resistor, this will decrease. So these are the points you need. First point, EMF does not change with increase in internal resistance. The second point, power dissipated by the fixed resistor, this will decrease. So the answer for this question is C. So you can see EMF no change. Power dissipated decreases. So the answer is C. For question number 37, it is given to us 4 identical resistors are connected in a circuit as shown in this figure. It is also given to us that battery has negligible internal resistance and EMF of the battery is equal to 30 volts. We need to find the potential difference between 2 points X and Y. It simply means that if we connect a voltmeter between X and Y, so what is the reading on this voltmeter? So this is what question is asking us to find out. So first of all, let's try to write down the given resistance. Let's say the resistance of this resistor is capital R, so the resistance of this one is also capital R. Resistance of this resistor is capital R and resistance of this resistor is also capital R because all these resistors are identical. Now these two resistors we can replace with one resistor and these two we can replace with one resistor. These two resistors are connected in series, so it means the total resistance of these two resistors is equal to 2R, and these two resistors, they are connected in parallel, so the total resistance of these two resistors is equal to R by 2. So we can redraw this circuit. So let's redraw this. And so this is our battery, so simply we can draw this one is the battery, and the EMF of this battery is given, that is equal to 30 volts. So this one is our battery. You can also draw like this. So it means this one is battery. It has many cells connected in series. So these two resistors we can replace with one resistor of resistance 2R, and these two we can replace with one resistor of resistance R by 2 because these two resistors are connected in parallel. Now we need to find out current in the circuit. So current in the circuit will be equal to EMF of the cell divided by total resistance. So the total resistance of this circuit, simply we can write down, this is 2.5 times R. We need to find out the potential difference across this resistor. Means our voltmeter is connected between these 2 points. This is our point X and this is our point Y. So we need to find out what is potential difference between X and Y. So the potential difference between X and Y is equal to current times the resistance. So we can say 2R. From here we can write down I is given, this is 30 divided by 2.5R, and this is multiplied with 2R. Now simply we can cancel this R with R. So we left with 30 multiplied by 2 divided by 2.5. Now if we solve this one, our final answer will be 24 volts. So answer for this question is 24 volts. Means the reading on this voltmeter will be equal to 24 volts. For question number 38, it is given to us a power supply and a solar cell are compared using the potentiometer circuit as shown in this figure. For this circuit, it is given to us the potentiometer wire PQ is 100 centimeters long and the resistance of the wire is 5 ohms. So simply we can write down here first of all, resistance of wire PQ is equal to 5.0 ohms. The power supply has an EMF of 2.0 volts and solar cell has EMF of 5.0 millivolts. We need to find out which resistance must be used so that galvanometer reads 0 when PS is equal to 40 centimeters. Now let's try to answer this one step by step. So first of all, we need to find out the potential difference across PQ. So we need to find out potential difference across PQ. But we need to understand the potential difference across PS. This is equal to 5.0 millivolts when galvanometer reading is equal to 0. So this is the first point we need to understand. So we can simply say that in this case VPS, this is equal to 5.0 millivolts. And the length of PS is also given, that is equal to 40 centimeters, and the length of PQ is given, that is equal to 100 centimeters. So we can find out the potential difference across PQ. So this is our main goal now. First of all, we need to find out the potential difference between P and Q. So we will start from I, current. Current passing through PS and PQ is the same because it is the same wire and there is no current passing through the solar cell. So we can say IPS, this is equal to IPQ. So this is the main concept. Now we can say that the potential difference across PS divided by the resistance of PS means RPS. This has to be equal to the potential difference across PQ divided by the resistance of PQ. In this case, we are talking about PS and PQ. We are talking about the same wire. For the same wire, resistance is equal to rho L by A. As the wire is the same, it means rho is the same and A is the same. So resistance is simply depending on L. So we can replace resistance with L. So we can say VPS over LPS. This is equal to VPQ over LPQ. So this is LPQ. So we can replace RPQ with LPQ because we have the value of L. So VPS is 5 millivolt. So I will write down here, this is 5 millivolt. So this is 10 to negative 3 divided by the length of this one. So this is 40 centimeters. Simply we can say this is 0.4 meters. VPQ we need to find out. So this is VPQ divided by length of PQ 100 centimeters. So simply this is 1 meter. From here we can find out VPQ. So if we solve this one, so VPQ simply will be equal to 0.0125 volt. So this is value of VPQ. Now we have value of VPQ, so we can find out the potential difference across R. So I will say VR. So we can find out the potential difference across the resistor R. So VR simply will be equal to the potential difference across this, or we can simply say this will be equal to EMF minus potential difference across PQ. EMF is 2.0 volts, so we can subtract 0.0125. This is the PD across PQ. So it simply means that EMF is equal to VR plus VPQ, if you're not very clear about this. So this is what we are using. We're using this concept. So now from here we can find out VR. So the potential difference across resistor R is 1.9875 volts. So this is value of potential difference across this resistor. Now we need to find out current. So how we can find out current? So I we need to find out. As this resistor and PQ, they are connected in series, it means current passing through this wire is the same as current passing through R. So we can say if current I is here, current I also will be here. and current I is also here. Current is the same because they are connected in series and there is no current passing through this solar cell. So I we can find out. So we have this resistor, means we have this wire, we have potential difference across the wire. So I will say this is I for the wire. Potential difference across wire we have found, that is VPQ, and the value is 0.0125, means this value. This is the potential difference across wire. And the resistance of the wire is 5 ohms. So this is given to us 5 ohms. So simply we can divide by 5 this. If we divide this one by 5, so value of I will be equal to 0.0025 amps. So this is value of current. And we have potential difference across this resistor. So simply we can find out the resistor, this will be equal to, mean the resistance of resistor R will be equal to potential difference across resistor R divided by current passing through resistor R. So VR we have, this is value of VR, and this is 1.9875. We need to divide by current. So this is 0.00, means 0025. If we solve this, our final answer is 795 ohms, and this is the value of resistance of resistor. So the answer for this question is C. This is the answer. Very nice question about potentiometer. For question number 39, it is given to us the table contains data for 4 different nuclei, P, Q, R, and S. We need to find out which 2 nuclei are isotopes of the same element. So the first thing we need to understand, isotopes of the same element have same number of protons. Means isotopes of any element, they have same number of protons. So this is the key concept we need. They have same number of protons. If you look at this table, we have nucleon number and we have number of neutrons. So we also need to understand how we can find out number of protons. So simply we can write on here how we can find number of protons. Number of protons is equal to nucleon number. So I will say simply nucleon number minus neutron number, means the number of neutrons. So here we have neutron number. Now if you look at nucleus P, for this nucleus we have nucleon number 10 and number of neutrons, mean neutron number is 5. So the proton number means P is the number of protons. Simply this is equal to 5, mean 10 minus 5. If you look at nucleus Q, it is given to us, it has 10 number of nucleons and neutron number is 6. So the proton number is 4, means 10 minus 6. If you go to nucleus R, we have total 14 nucleons and neutron number is 6. So the proton number is 8, mean it has 8 protons. But if we go to nucleus S, we have 16 nucleons and neutron number is 8. So the number of protons are 8. Isotope has same number of protons. So it means R and S, they have same number of protons. So these are isotopes of the same element. So our answer is D. For question number 40, we need to find out which particle is a fundamental particle. Fundamental particle simply means that it cannot be further subdivided. So simply we can say it cannot be further subdivided. Or we can simply say it does not consist of smaller particle. So we can say not consist of smaller particle. So another way to say this one, we can say not consist of smaller particles, and that particle we call is fundamental particle. Now we need to find out which particle is the fundamental particle. First one is alpha particle. This is not fundamental particle because it consists of protons and it consists of neutrons. And neutron and protons, they consist of quarks. So this is not fundamental particle. If you look at electron, electron is fundamental particle. So our answer for this question is B, because electron does not consist of smaller particle. So electron is fundamental particle. We cannot divide this one into smaller particles. So this is fundamental particle. So electron is fundamental particle. So this is fundamental particle. Neutrinos are also fundamental particles. Another example of fundamental particle is neutrino. So we can also write down neutrino. Neutrino is also fundamental particle. If you look at neutron, neutron is also not fundamental particle because it consists of quarks. Neutron has one up quark and two down quark. So it consists of smaller particles. So it is not fundamental particle. Proton also consists of quarks. Proton consists of two up quark and one down quark. So it consists of two up quarks and one down quark. So it consists of smaller particles. So proton is also not fundamental particle. So fundamental particle simply means that it does not consist of smaller particles, or simply we can say we cannot divide this one into smaller particles.